Welcome back, ladies and gentlemen. We are on to a new lesson on our fantastic journey of interest, simple interest, compound interest. Today's lesson is all about using a internet-based calculator for calculations of compound interest. And that's great. These things are quite useful. Unfortunately, what you'll find with this calculator, the URL is here in case you haven't grabbed it from the textbook. I've just got it sitting there in front of us that we're meant to use. In case you haven't noticed from visiting this website, it unfortunately has some very different terminology in it. It has terminology I've seen before. A lot of financial calculators look like this, and it's not necessarily nice if you haven't seen it before. You're probably staring at this going, there's a whole lot of lingo here that I've never seen before. All right, so what I'm going to do before jumping into any examples is explain what on earth you're looking at. Present value is essentially your initial value, the initial amount that you're investing or your initial amount of debt. Your initial amount you're investing is P. Present value here is P, the initial value, except as a negative. They have put a negative sign in front of it. Right? That's how you use this. So whatever your P value is, the initial amount of your savings, the initial amount of your debt, you're going to put it in there, in here, as a negative. I'm still waving my arms around as if you're filming me, and it's just a waste of time. We don't, for the purposes of what we're doing, have to worry about this or this at the moment. This stuff is for when you're dealing with things like home loans. This here, we're actually calculating future value, but I'll get to that. Payments is when you're dealing with things like home loans. So it's like, well, I've got this debt and I'm paying back this amount, and yeah, all sorts of really interesting stuff, but that's not what we're dealing with today. Not relevant today. Relevant for life though, if you want to work out your repayments on debts and things like that. But there's also a whole series of much gentler online calculators that banks put up now. For some reason they seem to want your business. I don't know why. Maybe they're making money or something. Anyway, future value. This is what we're calculating. This is essentially A. This is what we've seen in all our stop doing that. All our calculations as the final amount. So if you've invested your $5,000 and you eventually get something, we actually click FV to find the final amount. We're going to be doing that a bit in this. So you'll notice even in the data that's filled out at the moment, this is someone who has $5,000 invested at 5%. And down here, see how it says monthly? So it's for 60 months, which ends up being 5 years. And what you do is you click this FV value and it'll tell you what it's actually going to be worth in the future. FV stands for future value, but we've been using it as A in all of our working. PV is present value. We've been using that as P in our formulas, right? So PV, present value, is P. Future value, FV, is A. This is our interest rate. What's different in this thing is it's actually as a percentage. In all our calculations we've been doing lately, we've been doing it as a decimal. It says percentage, give it to them as a percentage. Less work for you. And this is the number of time periods, which also has a letter you're familiar with in our formulas. What letter do we use? N. Okay, so that's what you're staring at. And here, the compounding one, it has options: annually, semi-annually, that means twice a year; biannually, so that's twice a year; quarterly, every quarter; semi-monthly, which means every half a month. We haven't ever used that in class. Bi-weekly, that's fortnightly, every 2 weeks, so that's fortnightly right there. Weekly and daily, they're the options they're giving you in this calculator. I've seen this sort of exact setup on graphics calculators, those really funky, expensive things you might see some people using. It does occur a bit. In fact, I've got a scientific calculator that does a very similar thing with this sort of terminology. But again, important bits. Present value is P, future value is A, rates just your interest rate as a percent, and number of time periods is N. So from there, I'm now going to go through 4 separate examples of using this. You can see the website on the right-hand side. Let's boogie. First example, Clarence. Clarence invested $15,000 for 5 years at 2.5% with interest compounding annually. How much does he have at the end? So present value, the PV there in the machine, is the amount invested as a negative. So I'm going to make that negative 15,000. Next up, we have an annual interest rate, and it's 2.5%. So I can just put that in as 2.5. The time periods, we're working in years. It said interest compounding annually, and I said 5 years. So this is a simpler example, 5 years, 5 time periods, bang. Right? Got to be careful. The compounding is annually. I've changed the compounding to annually to make sure it doesn't stuff up. Compounding annually, and then click FV, which gives us A. Ta-da! Clarence, after 5 years at 2.5%, will have $16,971.12. That's the end of the story, guys. That's how much money he'll have at the end of his journey. That's example 1. Example 2. Hamish wants to invest his $4,800 for 8 years. How much more will he make at 5.8% than 5.3% if interest is compounded fortnightly? So in both situations here, we have the present value, which is the amount invested as a negative, is going to be negative 4,800, right? Because both scenarios that you're looking, I'll call them scenarios. Both scenarios, he's putting in 4,800. So let's put that in, that's easy. Both of them have the interest compounded fortnightly, so I can put that in. Well, they call it bi-weekly in here, so it's the same thing. The interest rate changes. I'm going to just wipe the future value because we don't know that. What's changing is the interest rate. So scenario 1 at 5.8%. That means that our annual rate is going to be 5.8. We're going to put that in as 5.8. And the future value, which is A, so let's put in an annual rate of 5.8. We can then click future value and it's going to tell us how much that is worth at the end. At the end, it's worth $4,853.78. The second scenario that we're comparing it to is when the interest is 5.3. So all I need to do is change that annual rate to 5.3 instead of 5.8, and click FV again. And it gives me our final amount he will have is $4,849.12. Now, let's go back to the original question. How much more money will he make at 5.8% than at 5.3%? How do we calculate that? He made that much money at 5.8. He made that much money at 5.3. How do I work out the difference? Well, I load my calculator and I go, 4,853.78. Take away 4,849.12. Just work out the difference between the two. Difference means subtraction. So the difference will be the amount he earned at 5.8%, subtract the amount he earned at 5.3%, which gives us a whole $4.66. Therefore, Hamish will make $4.66 more. Oh, no. I've done something terrible. Oh no. See, I've told it to calculate for 5 fortnights. That's not correct, is it? That's not correct at all. We need to have the number of fortnights in. You notice how I was thinking $4.66 seems a bit low, doesn't it? 8 years, and how many fortnights are there per year? There's actually 26 fortnights each year. Oh no! N is actually 8 times 26. N should be 208. Oh no! So our time periods here, the number of fortnights in 8 years, 26 fortnights in a year, there's actually 208. You're going to have to redo all that. See, this is why you need to be paying attention, right? I thought it was too little. Anyway, so at 5.8%, we'll actually have $7,630.09 cents. At 5.3%, we'll actually have $7,331.53 cents. That's a bit more like it, isn't it? 5 fortnights. There are not 5 fortnights in 8 years. Right, so fixing that up, at 5.8%, we got $7,630.09 cents. At 5.3%, it was a lot less. Subtraction, the difference is 298.56. Right, that's more like it. So Hamish will make $298.50 more at 5.8% compared to 5.3%. That's better. Sorry about that, people. Third example, let's get through this. Lily plans to invest. In fact, you know a good way of making sure we don't stuff it up like we did that before? Let's press reset so it's all reset. Lily plans to invest $240,000 for 4 years at 4.2%. How much will she make if the interest is compounded daily compared to monthly? So there's two scenarios. We want to know how much you're making if interest is done daily and how much of interest is done monthly. In both cases, the amount invested is the same. So PV, the initial amount will be negative 240,000. We can put that in with confidence. In both cases, the interest rate as a percentage is 4.2. So I can put that in as 4.2. Now, the time periods and the compounding are going to vary though. So daily, N, our number of time periods, it's for 4 years, but we need to work out how many days there are in 4 years. To do that, it's 4 years at 365 days per year. So if I go 4 times 365, N is going to be 1,460. And we need to make sure that the compounding is daily. So I'm going to put in 1,460 and daily. And I find FV, which is our A value. Lily will have $283,902.04. Monthly, we need to again think of how many time periods. There's 12 time periods in a year, but it's 4 years. So 4 years, 12 months per year, N will be 48. We've got to make sure that we send the compounding to be monthly in line with the question. So I'm going to change that to 48 and monthly, and we go future value. Whoa, I didn't click monthly right. That's better. And we get A is 283,821.53 cents. So we can see that yes, Lily will make slightly more money if she is compounding daily. We could put it in the calculator. I wonder if it will accept me doing that. No, it won't, will it? 283,902.04, subtract 283,821.53. We could say Lily will make $80.51 more, compound with interest compounding daily rather than monthly. There we go. So that's question 2. Make sure to answer the question at the end. It was asking, how much more money will she make if the interest is compounding daily compared to monthly? We needed to answer the question. The answer is $80.51 more. All right, so going down to the last one for today, this is one where they give you 2 different scenarios, 2.4% interest compounding weekly or 2.5%. I'll call this scenario A, I'll call this scenario B. 2.4% interest compounded weekly or 2.5% interest compounded quarterly. Which option should Sunday take? Let's do this. So in both cases, the amount you're starting with is the same. The present value is negative 420,000 because we always put the amount as a negative in this calculator. And I think everything else changes, doesn't it? Right. So scenario A, we have an annual rate as a percent, it's 2.4. So we can put in 2.4 and it was compounding weekly, so N the number of time periods. So it was 6 years, and how many weeks are in each year? 52. So N will be 312 if you put that in your calculator. So 312 time periods, and it said it was compounding weekly. And out of that, we will get A, the final amount of $485,035.21. Right, scenario B, same deal. Right, annual rate as a percent on this one is 2.5% from our question up here. So 2.5%. This time we're compounding quarterly. So N, I wish I'd stop making it uppercase automatically. So it was 6 years and there are 4 quarters each year. So in total there are 24 quarters over the time period. We need to make sure we've specified that it is compounding quarterly. And we've done that. So I put in 24 time periods and quarterly. I press FV and it tells me we will have 487,742.65 cents. Which one's bigger? Scenario B. Better off with scenario B, 2.5% compounding quarterly. They are the sort of challenges you need to be able to answer with this machine, with this calculator. Remember to put in your original amount, your P as a negative, in here is PV, your annual rate as a percentage. Calculate your number of time periods, which is essentially going to be, as shown, it's going to be the years times by the number of units in a year. Make sure to specify your quarterly or whatever you're using here. Make sure you've got your compounding units correct, and have fun, everyone. So it's not as awful as it looks. Cheers.